Okay, find the equation of the tangent to the curve y equals x cubed plus 4x squared minus 7 at the point on the curve where x equals 1. You need to remember when it says equation of the tangent, okay, we need to use what we learnt in coordinate geometry, right? Y minus y1 equals mx minus x1, okay? And for the equation there, notice we need a point that exists on the line of the tangent, plus we need the gradient, okay? So in terms of a point, well, we know it's going through this x equals 1, yeah? But of course, we need to work out what the y is, don't we? And we could sub that into the curve, because if you think about it, right, if my curve looks something like this, okay, right, and there's my point x equals 1, my tangent, okay, tangent is going to look something like that, isn't it? Okay, well, the tangent at the point x equals 1 is going through x equals 1, isn't it? Okay, but I need to find out what y is, okay? I don't know what y is, so I need to work that out. But I can work it out by putting it into the curve, because it lies on the curve, doesn't it? It lies on the curve. So we can say, look, when x equals 1, y will equal 1 cubed plus 4 times 1 squared minus 7. Now you can use a calculator if you want to check, but what's good is 1 cubed is just 1, 1 squared is just 1, so you get then this. So that becomes 1 plus 4 is 5. Take away 7 is minus 2. Okay, so we know now that it goes through the point 1 minus 2. Okay, that's where the tangent is at. Okay, so the tangent goes through this point. So we've got a point that the tangent goes through. What we need as well is the gradient. Okay, this value m here. Now to get the gradient of the tangent, we can get the gradient of the curve, yeah? And the gradient of the curve, of course, we can get by finding the gradient function first. So if we have y equals x cubed plus 4x squared minus 7, the gradient function, dy dx, okay, differentiate, bring the 3 down, so you get 3x squared plus 8x, okay, so take the 2 down, so you get 2 times 4 is 8x, and then that minus 7 just becomes 0. That's my gradient function. So I can work out the gradient when x equals 1. Dy dx will equal 3 times 1 squared plus 8 times 1, and that becomes 11. Okay, so that gives me the gradient. Okay, in other words, the gradient of the tangent is 11. Okay, the value of dy dx, the gradient function, remember, the value of it when x is 1. So if we've got the gradient of the curve when x is 1, we've also got the gradient of the tangent, because the tangent goes to the curve, x equals 1. So there's my gradient there. So then you get the equation then, because we've got the point and we've also got gradient. So the point it goes through, remember, is 1 minus 2. And be careful here. Okay, so we go 1 y minus. Now y1 is minus 2, yeah? So there's already a minus here, but you need to put minus 2 in for y1, so you're going to have 2 minuses there. Gradient is 11, x, and take away 1. And then, of course, this becomes y plus 2 equals 11x. And then when you multiply that bracket out, and then minus 11. Okay, and it's good practice to get everything onto one side, where you start off with the x term. And because I got plus 11x here, I maybe put a 0 there, so that'll be 11x. Take the y over, so it becomes minus y. You've got minus 11, and take the 2 over, so it becomes minus 2. So we end up then having 11x minus y minus 13 equals 0, and we've got our equation of the tangent at x equals 1.